Alright, good morning guys. Today we are going to be continuing Introduction to Angles 1.3. Our learning target today will be I can solve problems involving straight angles and bisected angles. Now in our previous video we covered collinearity, betweenness, and assumptions. We're just going to talk about assumptions really quickly before we continue on with the rest of our lesson. So, getting started. We talked about this in our last video, so I'm just going to kind of breeze through it. If you need to watch that video again to catch up on this information, please feel free to. But within a diagram, there's certain things that we can assume and certain things we cannot assume. And both are equally important. I may even say that things that you cannot assume is a bit more important than things that we can assume, just because if I assume something that I cannot assume, it may mess up my entire proof once we get into that in a couple days. So, things that I can assume, if I see a straight line, I can assume that's a straight line, and I can also assume that it equals 180 degrees. I can also assume collinearity between points. If I have multiple points on the same line, I can assume that they are all collinear points. I can assume that points are between other points on a line. So if I see a point that is collinear with other points and it is in between them, I can assume that point is between. Lastly, I can assume relative positions of points in relation to how close they are to each other, where they are at in relation to each other, and so on. So I can assume where those points are at on the picture in relation to all the other points. Now, things I cannot assume. I can't assume right angles. In order for me to assume that I have a right angle, I must have that right angle box in there. If there's no right angle box in there, it could be 89 degrees for all I know. But if that right angle box is there, then I can assume it's 90. Without it, I can't assume anything. Congruent segments. I need to have congruent marks on segments in order to prove congruency, in order to assume that. If those marks are not there, I cannot assume that they are congruent. Even if they look the same, even if they may even be the same, I cannot prove that they are the same without congruency marks or without statements such as segment AB is congruent to segment BC. So I either need a statement, I need congruency marks, or it needs to be explicitly stated. That's for congruent segments as well as congruent angles. Same thing applies. I either need a statement for congruent angles or I need the congruency marks on my angles. Lastly, relative sizes of segments and angles. I cannot assume their relative sizes to each other. So if they look like they could be congruent, I cannot assume that unless I have proof of either the tick marks, the congruency angles, or if they're both right angles, for instance. So again, we need to have proof in order to say that they are, in fact, the same. All right, so again, these are super important for proofs. Make sure that you guys do know them just to make sure that you're good to go once we hit the proof section in a couple days. All right, so we're going to go ahead and work on our assumptions here. So with this diagram as shown, so I have a diagram right here. There's certain things that we can assume. So go ahead and take a second, write out all the things that you can assume from this diagram using all the information from this page here. So, some of the things that we can assume, first off, I can assume that point C, is between points B and E, and also between points A and D. So C is in between. I can also assume that points A, C, and D are all collinear, because they all lie on the same line. And I can do the same with B, C, and E. Those are all also collinear points. They all lie on the same line as well. I can assume straight angles and straight lines, so I can assume that BCE is a straight line, BCE is a straight angle, and I can assume that BC is a straight line. Same with AC. AC is a straight line, and angle ACD is a straight angle. Creates 180 degrees. So those are just some of the things that we can assume based upon this diagram. Later on in the class, we'll actually learn more about what we can use with these diagrams and things that we can assume further. But we haven't reached all that material quite yet, and we'll get to it soon enough. So, should we assume on this diagram to the right here that points S, T, and V are collinear? Well, if we look over at this diagram, we have points S, T, and V. And since they all lie on the same line, we can in fact state that they are collinear. We can assume that. Can I assume that angle S is 90 degrees? This angle right in here that looks like it could be a 90-degree angle, can I assume that? Well, no. There's no box there. There's no right angle symbol. So if there's no box in the corner, there's no right angle symbol, then I cannot assume that's a right angle. So that is a no. All right. So yesterday we talked briefly about the triangle inequality theorem. We're going to go in a bit more depth here. The triangle inequality theorem. It states that for every triangle, of course we know a triangle has three sides, and those 3 points that create a triangle are non-collinear points. They're not on the same line. If this is the case, then if I have two sides of a triangle and I'm trying to find my third side, the two sides that I know, when added together, will always be greater than my third side, no matter which side I choose from. So if I choose sides AB and AC, or little c and little b, then those two sides added together should be greater than 11. Or if I chose sides little a and little c, if I were to add those two together, it should be greater than side b. So if I'm missing a side length here, I'm trying to find out what b is equal to. Well, then I need to go ahead and work on this a little bit and determine what range of values my b value can be. So to do that, I can go ahead and I can take my a value and I can say, oh, my a value is 11. So a is equal to 11, b is unknown, and c is equal to 6. So I know, first off, a plus b must be greater than c. So I can say 11 plus b, our unknown variable, is greater than 6. Well, from here, if I solve for b, I should be able to determine exactly which value I can go to. So if I subtract 11 from both sides, we're left with b is greater than -5. So my b value has to be greater than -5. And in this case, if it is greater than, or if it is at a negative number, does it have a distance? No. So it needs to be greater than 0 in that case. From here, I can also say a plus c is greater than b. So a plus c is greater than b. Well, if that's the case and I plug in my numbers, I have 11 plus 6 is greater than b. So that will give me 17 is greater than b. So my b value cannot be bigger than 17, but it also cannot be smaller than -5, or in this case, 0. Now, if I do my last one as well, b plus c is greater than a. We have b, which is unknown, plus 6 is greater than a, 11. Now, here's where it's nice, because if I get a negative number, then, and I do it again, and I just replace my order, and when I solve for this b plus 6 is greater than 11, you'll actually see that we get this as a positive number instead. Instead of -5, it'll turn out to be +5. So we subtract 6 on both sides, and we get b is greater than 5. So I know that b must be larger than 5, b must be larger than 5, but it must be less than 17. So b is somewhere in between 5 and 17. Now you may be like, Mr. Garner, what about this -5 over here? That no longer matters, because again, I can't have a negative value for distance. So if it gives me a negative, we can't have it anyway. Try out the other two equations. We're looking for the positive answers here, because the positive answers are telling us, hey, this line right here, this line segment has a distance. If it's a negative answer, then of course we can't have negative distance. So again, b must be between 5 and 7. All right, moving on. The measure of angle 1 and angle 2 are in a ratio of 4 to 5. Now, I really like this question. That comes up quite often, so keep that in mind as you're working through it. If you need to pause the video now and try it out, please feel free to. I'm going to go ahead and start working on it myself. So, we have angle 1 and angle 2, respectively. These angles are in a ratio of 4, that's angle 1, to 5, which is angle 2. We want to find the measure of angle 1. Now, looking at our diagram, can I assume anything? Absolutely. We see a right angle box right there. That's 90 degrees then. So that angle is automatically 90 degrees. Now, along with this, since we're in a ratio of 4 to 5 with angles 1 to 2, I can just give each of these a variable. So I'm going to put a variable next to each of these numbers. I have 4x to 5x. That's what our ratio is respectively. So angle 1 is 4x, angle 2 is 5x, and I can go ahead and draw those on. 4x and 5x here. From here, well, I know that we can use the angle addition postulate. So our two small angles, when combined, will equal the larger angle. So we can say 4x plus 5x will equal how many degrees? Well, it will equal 90 degrees. If I combine like terms, this will give us 9x equals 90. And when we divide both sides by 9, we find out that x is equal to 10. Now at this point, again, we're not done here. We haven't answered our question. We want to find the measure of angle 1. That's our goal. So I'm going to take this 10 here that we just found, and I'm going to plug that 10 in for the x in angle 1. So I just plug it in right over there. From here, we have 4 times 10 equals the measure of angle 1. So the measure of angle 1 is equal to 40. And again, this 4 times 10, it's just from this 4x right here. That's where it comes from. That's our answer. The measure of angle 1 is equal to 40, which means the measure of angle 2 is equal to 50. All right. Continuing on, our last problem of the day. Given measure of angle DUM is equal to 4x minus 5. So DUM is equal to 4x minus 5. I can write that down here. 4x minus 5. Measure of angle BUM is equal to 9x minus 40. 9x minus 40 down here, DUM. And then we know UM splits angle DUB in half. So what is occurring is we have a ray that's here, ray UM, and this ray is cutting our angle in half. Well, if I cut something in half, it should be the same on both sides. It should be equal. So therefore, I can say that these two angles are congruent to each other. Angle DUM is congruent to angle BUM. They're the same. And what this ray is called is it's an angle bisector. And when I say bisector, I just mean a point, a line segment, a line, a ray, anything that cuts a figure into two equal parts. Now, bi means two, like bicycle, and sectors is just referring to the angles, what's left. We're sectioning this off. So we're cutting it into two equal angles here. And so that makes these two angles congruent. Since again, it's cutting it in half, it should be the same on either side. Now, if two things are congruent, that means that they are the same. And if two things are the same, we should be able to set them equal to each other. So this will lead to angle DUM is equal to angle BUM. So 4x minus 5 is equal to 9x minus 40. From here, we can go ahead and solve for x. I can do that by subtracting 4x from both sides. That will leave us with negative 5 equals 5x minus 40. From here, I add 40 to both sides, which will leave me with 35 equals 5x. And then lastly, dividing both sides by 5, we find out that x is equal to 7. All right, awesome. We found out what x is. X is 7. But what are we actually looking for? Well, we're looking for the measure of angle BUM. So I'm going to take this 7 down here, and I'm going to plug it back in for the x within the angle BUM. So it's just replacing this x here. So we're now left with the measure of angle BUM is equal to 9 times 7 minus 40. This will give me 63 minus 40, which is equal to 23 degrees. So the measure of angle BUM is 23. All right, That is it for today. We have now covered our learning targets about collinearity, betweenness, and assumptions, and we can also solve problems involving straight angles and bisected angles. Now, we will be dealing more with straight angles and bisected angles next week as well, but just keep in mind that is it for what we're covering today. So, other than that, the homework is posted in Schoology if you guys need it, and if you have any questions, please leave them in the comments below. Thank you guys for watching. I'll see you all later.